And then did a master's degree at the University of Massachusetts. Had a job for 2 years in New York City where I was a forensic structural engineer. So working on existing buildings, assessing problems that have occurred in existing buildings, whether it be excessive vibration or cracking or water damage or whatever, and usually designing fixes for them as well. Most interesting project with that is probably I worked on the Empire State Building.
First thing at the top of mine is welcome to Brooks. This is a fun social experiment as part of our ClearCalcs Culture Club. Today we're here with Brooks Smith. So maybe Brooks, you can spend a couple minutes introducing yourself and tell us more generally about who you are.
Yeah, sure. So thank you, Julian, for the invite for this. My name's Brooks Smith, and been with ClearCalcs just over 5 years now. I think August of 2018 was when I first joined. My title at this point is Head of Engineering R&D here, which is a little bit of a vague title. Basically, it means we have a structural engineering team and a development team, and I'm the bridge in between the two. I'm the person who knows a bit of the structural engineering and a bit of the development. I am a licensed and chartered structural engineer, licensed professional engineering licensure in the United States, and I'm a chartered engineer in Australia. I still first and foremost consider myself a structural engineer, and it is the area that interests me most, I would say. And I don't really see that changing too much. So my accent is from the United States, even though I'm living in Australia now. I grew up in the US. I did all of my schooling through university in the United States, have a master's degree as well from there, and eventually moved to Australia. And I'm now permanently based in Melbourne.
Awesome. I think preparing for this, travel was definitely one of the topics that came up. So we'll probably get there as to how you're on the other side of the world. And I think the first question at the top of mine is as a little bit of an icebreaker. At the moment, is there anything in particular in your life that you're particularly curious about or you're currently working on?
I think the thing I've been most paying attention to, learning the most about, reading the most about, has been around best practices in how to package and distribute and develop Python projects. So I'm the primary maintainer of 2 open source Python projects, both doing different types of finite element or finite strip analysis so they're structural engineering packages written in Python. Been making a lot of updates to them lately to add full type checking, to use modern conventions in Python packaging. Slew of just random convention updates.
Maybe not, I'm trying to avoid going too deep in the rabbit hole. Are these open source projects?
They are, yes. So one is called Anastruct, which is a general purpose 2D finite element analysis package. And the other is called PyCUFSM, which was my first open source project. That is a Python port of what was originally a MATLAB program called CUFSM. Does finite strip analysis for any thin-walled section, but particularly cold-form steel is where it's most applicable.
Wow, amazing. And I guess if we rewind the clock a little bit to before your journey into Python, can you tell me a little bit about what it was like growing up in the US? How was that chapter?
Well, I guess I grew up all over the Northeast US, originally in Connecticut, and actually specifically in the town of Newtown, Connecticut, which is unfortunately known for one thing, and that is elementary school shootings. So that's actually probably something that got me a bit more interested in politics and is one of the long-term politics of the United States. Probably the biggest reason why I ended up overseas. Not any one president, not any one particular policy, but just prevalence of guns, poor safety net. Yeah, just the overall longer term politics in the United States. I don't really see changing anytime soon. But anyways, after that, yeah, I went to Dartmouth College for my bachelor's degree. Spent like 6 years living around what's known as the Upper Valley of New Hampshire and Vermont, and had my first, I guess, career job up there, where I was a tester for ANSYS, one of the really big and general purpose engineering software packages. So I helped test that software. And yeah, then did a master's degree at the University of Massachusetts. Had a job for 2 years in New York City where I was a forensic structural engineer. So working on existing buildings, assessing problems that have occurred in existing buildings, whether it be excessive vibration or cracking or water damage or whatever, and usually designing fixes for them as well. Most interesting project with that was probably I worked on the Empire State Building.
Yeah, I read about this.
Yep.
Tell me more.
So it was actually not a huge project. It only lasted a few weeks of time, but yeah, it involved some on-site work to look at why there was concrete degradation and some spalling of concrete in the basement of the Empire State Building. That is also where I discovered just how poor some of the public records were of where in the world the electrical cabling may or may not be running through. We were able to just walk around some parts of the basement there, literally with a hammer, just whacking off loose pieces of concrete.
Right.
If you can knock off a piece of concrete with a hammer, it's not in good shape.
Oh, because how far does the history of the Empire State Building go? Like 40s, maybe?
I'm blanking the year. I think it was a little earlier than that.
Well, if it is earlier, how would you go about reconditioning a building that's almost like 100, let's say 90 years old? Like when you have, I don't know, spalling concrete and whatnot. Like, how do you go about doing that for a massive skyscraper?
Well, you hope that you don't need to fully replace any parts. Replacing is harder because you need to put in temporary supports and then re-pour your wall or slab or whatever it is. It's a lot easier if you can repair what's already there and hopefully in the process also stop any further degradation from happening.
Right.
So the most common reason for concrete spalling is the rebar or the reinforcement inside of it starts corroding. As steel corrodes, it expands, which pushes out the concrete, which breaks the concrete, causes concrete to fall and spall.
Oh, wow.
So that can be caused by water infiltration. Water over time reaching that reinforcement will cause it to rust. Can also be caused by salts that are getting in through various means, or even poor mixtures of concrete originally. So yeah, I forget what it exactly was for the Empire State Building, but yeah, fixes for that may include just patching any concrete that wasn't serving a structural purpose. Sometimes if you get just a couple centimeters, just an inch or two of concrete that falls off, it's not actually structural at that point. It's more a visual thing. So you fix any visual flaws like that, and you put in something to help prevent further corrosion. So that could be zinc, which zinc favorably corrodes instead of the steel. So the things that cause steel to corrode, if you have zinc near that steel, the zinc will corrode instead, and the steel will not. So put some zinc in place. And there's also electrolysis processes as well, where you can put like small electrical currents through the steel, which will help prevent it. A few solutions like that.
Did you know early on like that you were going to be involved in projects like the Empire State Building? Like how did you end up in engineering in the first place?
No, absolutely not. Well, I guess back in the day, I originally at one point thought I was going to be a theoretical physicist. I love, and I guess still love, the thinking about quantum mechanics and relativity. It's just such weird behavior. Heisenberg uncertainty principle, the behavior of gravity and the behavior of time dilation as you approach the speed of light, behavior of quarks, and sort of the weird bits of science like that really stretches your brain. As I got more into that in university, I just kind of got tired of what I saw as it involved very little other than mathematical proofs, just doing mathematical proof after proof after proof. I wasn't very good at, and I just didn't enjoy. I enjoyed thinking about the concepts, not about, the vague mathematics behind it. So I still like math. So I sort of saw engineering as the place where I can actually plug numbers into the math instead of everything being a variable. So, I picked up engineering and just gradually found that the area of engineering that clicked best for me was structural, was picturing physical things. I think what I thought I was unusually good at was being able to picture something physical in my mind and rotate it around, imagine what's going to happen if you press on it in different ways. Yeah, I can visualize that fairly easily.
Did you have any particular like role models around you at the time, like who kind of showed you what engineering looks like early on?
I had some favorite professors, but I think I've not actually been one to take on individuals as role models very much. So I'd say I had a couple of professors who I think were more inspiring. Particularly, I think my Professor Simon, who was my professor of numerical analysis, which was a cross-department course that was between the math department and the engineering department.
Ooh.
Actually, I think and computer science. So it's actually sort of perfectly where I am now.
Yeah.
All of the areas that I'm interested in, here's how you'd combine them together. He was a guy who would bike to the university every day and come into class barefoot and just spend the entire time writing away on the chalkboard.
Whoa. So like writing away on the chalkboard, like making stuff on the fly versus like reading off wow. And I guess maybe then fast forwarding a little bit, I was curious to ask you actually this particular question, which is, what does being an engineer mean to you? Have you figured out what that might look like?
I think the biggest thing it means is finding practical solutions to real world problems. Obviously, I'm in structural engineering, so that comes in the form of making something physical stand up and be resilient to natural disasters or just day-to-day loadings. But in other types of engineering, it might be climate resilience, most efficiently solves a problem, that most efficiently makes a television work. Practical real-world solutions to real-world problems.
And maybe this is something I learned about you in reading a bit of your writing on the internet. Even though I've been here for a year, maybe that's not long enough, is that I found out that you were involved in previously with Engineers Without Borders. which was amazing to find out just from afar. So I get to ask you about it today, which is awesome. Maybe you can tell us a little bit about how you found out about Engineers Without Borders and what your experiences have been like.
I'd been aware of the organization for a long time. In the United States, they are pretty closely affiliated with the American Society of Civil Engineers, which is the main professional body in the United States for civil and structural engineering. So, yeah, I've been aware of them for a while. Their overall mission interests me quite a bit, and that's to essentially use engineering skills to help anyone in the world who needs those skills and doesn't have ready access to them. So most commonly that means more impoverished nations. It can also mean more impoverished or deprived parts of an individual country. But yeah, I like that mission. So overall, I want to make the world a better place. And that's the legacy that I want to leave behind. I don't care if my name's attached to it or not, but I want the world to be a better place. When I lived in Hong Kong for a couple of years, I had a fair bit of available time in which that I could devote to Engineers Without Borders. And I was fairly heavily involved with it there. Yeah, did more planning than actually executing, because it was still a fairly young organization in Hong Kong. But we visited Cambodia and Myanmar and helped design some projects there that I think one of them was executed later. I think the other one didn't actually end up happening, but fascinating countries, beautiful countries, and yeah, some interesting work.
What in those countries, what were the problems you were trying to solve?
In Cambodia, it was helping another charity to build schools in rural areas. And obviously you need an engineer to make the school building actually stand up. So we went there to see what soil conditions were like, what additional facilities we would need to put on it. How do you have a toilet in an area that has no sewer system, that has no water supply piping? What all do you need to put in place to have a successful building? And in Myanmar, it was looking at water supplies for a northwesterly province of the country. So we were trying to help a couple of villages build a fresh water system that could be sustainable for them and provide enough fresh water for the communities.
And were the conditions on the ground what you were expected going into them? Like, or was it surprising?
Also, I didn't really know what to expect. I really hadn't had much experience, and I don't want to sound like, white savior tourism, which is its own problem. But yeah, I didn't really know what to expect, and it was enlightening to be able to see how other people in the world live and what advantages and disadvantages they have and different lifestyles.
As you spoke about like building a school, I thought about like in Asia there might be monsoon seasons and how that might affect how a building gets designed or constructed, or both. So, wow.
Exactly. Yeah.
So that at some point you've moved from the US to Hong Kong, and then eventually from Hong Kong to Melbourne.
Yep. Yeah, it was actually spent a year and a half in Australia when I just had wanderlust. And Australia made it cheap and easy to get a work visa. And then that was only on a temporary visa. Then my now wife and I moved to Hong Kong for a couple of years, where we figured we wanted to live somewhere unique that may not necessarily be good for raising a family, but that we probably would never end up in again. So Hong Kong, I think, does indeed fit that bill. Not sure I want to actually live there now, unfortunately, with some of the political turmoils going on there. But yeah, we both, my wife and I both really liked Melbourne. And as an engineer, her as a special needs teacher, we both have careers that most countries, including Australia, believe they need. So it was relatively easy to get permanent residency here. So we're permanent residents now. We own a house. This is where we're staying.
Amazing. Wow. While we're on the topic of travel, I might butcher the pronunciation, but I've heard that you spent a bit of time hiking on this trail, and it's Appalachian Trail. Is that close?
Your hesitancy on that's a bit amusing, and almost no matter what you did, you'd be correct for some part of the U.S. The southern states tend to say Appalachian. Northern states tend to say Appalachian. So yeah, you'd be correct with either. But yes, in between that forensic engineering job in New York and the moving to Australia, I spent 6 months hiking the Appalachian Trail. And that was I wanted to have some kind of big adventure before I had a family. I wanted to get out of New York City. I think at heart, I'm a bit of a country boy. So after having lived in New York City for 2 years, it was just enough. Needed to leave a big city like that. Hard to get more the opposite of the city than, living in the woods for 6 months. And I'd been thinking about just something like this for a long time. So Appalachian Trail was amazing. It was a time to reflect. It was a time to meet a lot of very interesting people. It's one of the things I love most about the trail. Is everyone's attracted to it for a different reason, and people are attracted from all walks of life. Met motorcycle gang members. I met mortuary assistants. I met an airline pilot who ended up helping me get a cheap ticket to come to Australia originally. Yeah, people from just all walks of life and all ages too. It's amazing. Met 15-year-olds hiking, and I think it was an 87-year-old hiking it as well. So incredible. And obviously beautiful views everywhere.
Right. To me, like in my head, like assuming like you made the time, you created space between your careers to like do something for, let's say you had 6 months. To me, it doesn't seem very, it doesn't sound to me like it's a path that a lot of people would take. Like, oh, I'm going to spend 6 months on this trail, like hiking. Do you have a sense of why you chose to do that when you could have, like, I don't know, gone to the beach or hung out in a forest or like put your feet up? But no, you were hiking and going on this adventure. Do you have a sense of why?
Well, wanting just something that was more of an adventure. I guess I've always also loved the outdoors. And of course, I'd only had a full-time job for 2 years. I didn't have a whole lot of savings, a whole lot of money available. And well, living in the woods with just the stuff on your back, not needing to pay rent to anywhere,
Right.
It's not that expensive. I think over the 6 months I worked out, I spent $5,000 or $6,000 total. So, I did have that much in my savings, and I could afford it.
Wow. It's amazing. Wow. And then after the trail, you left for Australia?
Yep. Yes, I've moved around a fair bit. So yeah, after that, I came to Australia for a year and a half.
Right. And then maybe this brings us back to where we are today, which is, how did you find ClearCalcs in the beginning?
Originally, just seeing a job ad that ClearCalcs had posted on Seek, one of the big job boards in Australia here. And I saw that they were looking for a structural engineer, preferably with programming experience. And the company was looking to expand to the United States.
Oh.
So I read that like, so I already know US codes. I'm a structural engineer who's licensed there and chartered here. And well, I have a fair bit of programming experience as well. They're going to offer me a job. Okay. Like unique set of skills, and I think just right place at the right time. Happens to see a job ad that, yeah, just fit perfectly.
Mm. Did was the ClearCalcs mission and vision something that was clear at the time, like in the beginning?
Yeah, it was fairly clear, and I think the overall vision hasn't changed significantly. And it's all based on the observation that a lot of engineers have a lot of good tools already for analysis. So for creating big finite element models of a building to accurately model how loads are transferred. But there really weren't, and still kind of aren't, other good tools for doing design, for actually figuring out how big does that beam need to be to abide by the standards and the codes in the local region. Engineers have tended to create their own calculators for that and tended to do that in Microsoft Excel, which is an absolutely awful platform for engineering work. It's great for accounting. It was designed for accounting, has a phenomenal use, but understanding and creating a quality calculator that's A13 plus B27 divided by C86, whatever, like
on sheet 57.
Like, yeah, give me a formula that I can actually type in WL squared over 8. Cool. I know exactly what that formula is doing. And what those variables are. That's not something you can do very well in Microsoft Excel. So, yeah, ClearCalcs has gradually expanded to originally we were 100% creating our own calculators, and now we're moving towards having a public builder that could be used by any member of the public to create a clear and transparent calculator, which, yeah, I still believe in that vision and still think it's the right direction to go with it. Still think it's something that's been missing in much of engineering, and not just structural engineering as well, for quite a long time.
I think one common thread, or maybe a word that comes to mind, is like quality. Are there particular things that come to mind when you think of that word? Like, what does quality mean to you?
So I have a lot of thoughts around quality, partly because of my first career job with ANSYS, where I was a software tester. It was my job to make sure that the next release of ANSYS was as free of errors as possible, and especially as free of calculation errors as possible. It's one thing for an error message to show up for a user. It's another thing for a result that kind of looks right to show up, but that result's actually wrong. So I think about still from that time, different classes of problems that can occur in software. Everything ranging from spelling mistake that's essentially inconsequential, just looks sloppy, to full-blown result that looks correct but is actually wrong. I think overall, quality means to me both reliable and accurate results, and also something that you feel you can trust.
Yep.
So those are, I think, two sides of the same coin, but they come from, your software can be as accurate as anything, but if it's a black box, if I just type in some numbers and then some stuff happens in the middle and then it gives me a couple numbers of results, well, I don't really know. If there's no way for me to check that it did the calculation correctly. It's why I really believe in ClearCalcs and the mission there of being clear and transparent, showing every equation. Most people are probably not going to click through every dinky little equation and double check every single thing, but it's there. If you don't fully understand a calculation, go take a look. It's all there. There's descriptions, there's formulas. It'll show you exactly what we're doing.
Let's say we were stuck in a terrible Microsoft Excel only world for engineering calculations. In that sort of world, how would engineers help build that trust for when someone else like reviews their work? Were there like patterns that people would follow, or particular, I don't know, practices?
The most common practice I think I ever saw was just having other people review your spreadsheet. But I remember when I was a forensic engineer, some of my colleagues would joke that I ended up creating spreadsheets that were nearly sentient because they had so much complexity in them. So when you reach that level of complexity, it's just really hard to actually be certain that everything in there is completely correct. And we did occasionally find problems later than we would have liked in a spreadsheet. Just, again, because the equation doesn't say WL squared over 8. It says A17 times B whatever. Yeah, it's hard to follow. The best you could do was double click on a cell and it highlights for you each of the other cells that are being calculated. Overall, I've not seen great practice with Microsoft Excel for quality. Usually it's one engineer who writes something and maybe somebody else checks it. But yeah.
Yeah, I think that from the few practices that I've seen, like maybe knowing that so and so pays high attention to detail, and then like relying on that, say, person's like social reputation, like, oh, this spreadsheet came from that person, I should be able to trust it. This person is trustworthy, he made the spreadsheet, I'll just use it and pretend that the black box is reliable was maybe one mechanism. But yeah, wow.
Yeah, reputation's the other big thing in there. But reputation can also be misleading. Because can often happen is older engineers have a lot of experience. They've probably designed a lot of things very successfully, but that means that you can end up just taking kind of a finger to the wind approach for design. That means that an engineer can say, yeah, it sounds like that that amount of load on that retaining wall should probably mean a 3-to-1 depth ratio. Well, okay, but prove it. Show me. Show me that that's the case. Show me that that's still the case with this year's revision of the standards, not just the 1984 version of the standards. So sometimes that experience can actually work against people as well.
I think within the software, let's say the software industry, like one of the great practices to me is the whole flow around like peer reviews. When you put up some code or you adjust some code or do whatever in a system, your code has to get reviewed by a peer. Is that a concept even within the engineering industry?
It is. It's in structural engineering, it's kind of an enforced practice in that one engineer has to be willing and able to put their stamp on a set of plans. Now, the United States is a little stricter with this, and I look forward to Australia kind of adopting, and they gradually are, some of the practices the US has, where that person always remains the one person who is primarily liable for any problems that occur in future in a building. Australia still ties some of that liability to companies, which means that if a company goes out of business, you're just kind of screwed. There's no one there who's actually going to stand up for what was designed. But in general, you need one engineer who's willing to sign off, who's willing to put their name, their reputation, their financial assets on the line for a design. And once you have more than a single story house, you'll have multiple engineers involved. You might have a junior engineer go do the initial design or the design of X component of the building, and then it ends up being signed off on by one senior engineer. So essentially that forces a peer review to happen at some stage of the game.
Right. From the outside looking in, it seems like professional accreditation within the engineering industry is important. What is that process like? For example, how did you go about being accredited as a professional engineer? How does one do that?
So I originally went through the process in the United States. I can talk a little bit about the differences afterward with how Australia does it as well. But in the United States, once I had my bachelor's degree in engineering, I was able to sit down for a day-long exam. And if I scored some sort of minimum score on that exam, I formally became an engineer in training, EIT. That gave me that post-nominal I could put on my name, EIT. Once you have that engineer in training, you then need to, the requirements vary slightly state to state, but in general, you need to have about 5 years of practical experience doing engineering work. You need to have at least 2 or so other licensed engineers willing to recommend you and say, yes, I think this person should become a licensed engineer. And you need to pass a 2-day long exam. So, those are the 3 main components: just experience, recommendations, and passing the long exam. In Australia, that differs a little bit in that there's not formally an engineer in training equivalent. You still need about 5 years of experience, and you still need recommendations from other chartered engineers, but there's not the sit-down exam. Instead, there's a series of interviews that you have to do to essentially prove your knowledge via essay questions.
Wow. If you become accredited in the US, does that transfer over easily into other regions?
So in the US, the accreditation is state by state. Transferring to another state in general is just an exercise in government money making. It's you pay a registration fee to another state and submit them a thing that says, yes, I met the requirements there, so I should also meet the requirements here. A little more complexity in California in particular. Just they're stricter on some of the requirements because of severe earthquakes being a major part of structural design. Transferring internationally is a little more complicated. There you need to, there's a series of treaties that have been signed by respective countries that have mutual recognition for each other's academic degrees and for at least components of the rest of the accreditation process. And some of that ends up being weird. For some reason, Australia's treaty relationship with the US only covers Texas. So you can only transfer a Texas license to Australia. I don't know why, but yeah. So technically I'm licensed in Texas in the US, and I was able to transfer that to Australia with some form work and some additional assessment that they had to do. But for the most part, it was just paying some fees and filling out some forms.
Right. And what does it look like? Does in terms of like continued practice as an engineer, like is upskilling part of it?
Yes. In structural engineering, again, this varies jurisdiction to jurisdiction exactly how much you need, but there's always some form of continuing education requirements that every jurisdiction has. In Texas, it's 30 hours of professional development in certain categories per year. In Australia, it's 300 hours every 3 years. Australia is also more flexible as to what it defines as professional development. In Texas, it needs to be more of a formal class or something along those lines. Australia can be reading materials to even in some cases. So,
right.
Yeah, there's very much an intention of, as a structural engineer, it is your obligation to keep up with modern practices and changes in the codes and standards.
And I'm guessing, if not, that accreditation would lapse by some standard.
Yeah. Texas does random audits. I've been audited once before, and Australia does audits every 5 years, I believe it is.
We've spoken a lot about accreditation, and one of the things that comes to mind, maybe it's a little bit tangential, we'll see. I was thinking about, and I was curious to ask you, like, for young people who are coming up through high school, coming up through university, or any other pathway, like, would you have any particular advice to share with them?
I think my biggest advice would probably be to experiment around, figure out what exactly interests you most. Because there's no one pathway here. Even if I say I'm a structural engineer, it's a pretty broad area. Are you a forensic engineer where you're dealing with existing buildings? Are you a residential engineer where you have an entire building you're designing by yourself? Are you a bridge engineer? Are you a skyscraper engineer and helping to co-design in a huge team some iconic building? And there's different materials that you can work with that all have different advantages and disadvantages. I've always been fairly interested in environmentalism. So when I was even first looking for a graduate program for myself, I specifically looked for one that had courses in wood and timber design. That's not actually available everywhere. So a lot of the big engineering programs really only focus on steel and concrete. And yeah, I guess the other piece of advice I'd have is, don't be afraid to move around. Don't feel that you need to stick with one company and grow through that one company. Your interests will change. And having a broad base of experience is really valuable. It's been incredibly valuable for me in ClearCalcs in software development to have been a forensic engineer, because it means that I know better than many like new design engineers what might go wrong. What are the things that we could guard against in some of the calculators we create?
Wow. I think, not sure if this is totally appropriate, but one of the things I really appreciate about getting to know you, Brooks, is like how well you articulate like across like a range of topics. It can be like super simple. It can be like, how do you turn the kettle on, to like something like, I don't know, like cold form steel. I can probably listen to you for like hours, so I might go back and watch some webinars after this. It makes me think like, unfortunately, we only have a limited amount of time today, and I haven't asked you questions about things like, I don't know, steel foam. I still remember that model you had brought along at one of the reset weeks, and I was like, wait, you're telling me like I'm holding this thing, but then from that moment, I realized that you had actually done active research on it, which blew me away. So maybe it's a topic for one of the future session, maybe. And maybe to close, is there anywhere on the internet that people could learn more about you? Like, is there a particular place you point people to read your writing or anything like that?
So I've never been particularly prolific with like social media posts or blogging or much along those lines. I like talking about these things, and by all means, feel free to reach out to me with questions, with just wanting to shoot the breeze on cold form steel or porous metals as a new material or whatever it is. The area where you can probably find some of the most information about me is on my LinkedIn profile, username SmithBH on there, or on my GitHub account, where, as I mentioned, I maintain I'm the primary maintainer of 2 open source packages and contribute to a couple others. Smith120BH is my username on there. Yeah. And all of those, I think, are linked to each other as well. So you can find my ResearchGate account as well, where you can see all the publications I've had and whatnot as well.
Awesome. I think that's a good place to close. Thank you, Brooks. That was so fun.
Yeah, thanks very much, Julian. Take care.